guys, this is acid-base video 3. To complete this, you really need to have your packet next to you, your reference table next to you, and a calculator. I do want you to try these along with me so you can make sure you're getting the right answers. So we're going to today talk about titration and the neutralization net ionic equation. They did start asking you in your textbook problems about net ionic equations. So I wanted to go over those. And titration is our last thing. So we're basically doing packet pages 10 and 11 today. We'll start on page 10. So on page 10, you already should have the top filled out. So basically where I'm drawing this line, we're doing everything below. Top should already be filled out. So we're talking today, let me move it down, about acid-base titration. So let's highlight that. Titration is a lab technique that helps us to determine the concentration. I'm going to write right over pH. Really, I'm focusing on the concentration of an acid or base. I'll base this off of using pH indicators, but it basically determines your concentration, or maybe it is going to determine a volume. So there is an acid-base formula, and that is from reference table T. So right now I should be flipping to the back of reference table T. And there you will see this equation. Listed under titration, MAVA equals MBVB. It also lists for you what those mean. So when they say MA, that is actually the molarity. It stands for the molarity of your acid. But they list it as the molarity of your H+. Well, that's because acids have H+. Same thing with your bases. It's MB because it's the molarity of your OH-, but bases have OH-. So think of it like molarity of your acid times the volume of your acid equals the molarity of your base times the volume of your base. And another thing to note, I should have noted this up here, when you see this word titration, you should be thinking neutralization. Titrations are when we will try to neutralize something. So, for example, let's try a problem. I want this problem written in your notes. So, example. What volume of 2.5 molar HCl is needed to neutralize 25 milliliters of 3.0 molar NaOH. So if they ask me this problem, here's what I would think. I see this word, neutralize, and if I see this word, I want to think titration. And if I think titration, I want to think go to table T. So I'm going to go to table T. Let's see what else that we have. Well, the titration formula is MAVA equals MBVB. So let's see, we have, here I see this molarity is of HCl, so my molarity of my acid is 2.5 molar. It said what volume, so my volume of acid is question mark. I don't know that one because they want me to solve for volume. And then it says I have 25 milliliters of 3.0 molar NaOH. So my molarity of my base is 3.0 molar my volume of my base is 25 milliliters. It's okay if it's in milliliters. I don't have to change that to liters, as long as I realize that my other volume will also be in milliliters. So it does not matter milliliters or liters in this equation as long as that is consistent. Your volume of acid and your volume of base has to be in the same unit. Okay, so now I can plug in and I say, okay, I know my molarity of acid is 2.5, my volume of acid is X, my molarity of base is 3.0, my volume of base is 25. So I can go ahead and solve for this. So I know that if I multiply here, I've got 2.5x equals 3 times 25 is 75. Divide by 2.5 to get that x. So I got to do it over here, 2.5. So I'm going to get x equals, let's see, 30. Now if I'm thinking what's my unit, well, it was a volume that I solved for. My base was in milliliters, so my acid's in milliliters. 30 milliliters. So see how I was able to solve? Here I could solve from a volume, but if they gave me two concentrations. So what you're going to notice when you do these types of problems is they're going to use either the words titration or neutralization. They're going to give you 3 of the 4 variables. They're either going to give you 2 concentrations and 1 volume, or 2 volumes and 1 concentration. You'll figure out the other. We'll be doing titration in class next week. But one thing that is important is I also need to kind of notice, is the acid monoprotic? So let's think what that means. Well, mono means 1. So if they're asking if it's monoprotic, remember I could call hydrogen a proton if it's H+. So monoprotic means 1H. Versus if I'm diprotic, let's think, di means 2. And if I look here as example, H2SO4, so diprotic means 2 H's. So if I'm triprotic, tri means 3. Oh, look, H3PO4, 3 H's. The problem is I have to pay attention to that because they told me that actually my MA was not just my molarity of acid, it was my molarity of H+. So if I'm looking at H2SO4, I have 2 H's. So for example, let's say I have 2 molar, 2.0 molar H2SO4. If I have 2.0 molar H2SO4, I really am going to have 4.0 molar H+ concentration. That's very important. Notice what I did to that number. I took this number, 2.0, and to get to 4, I multiplied it by 2 because I have 2 H's. So that molarity is showing you your concentration of your H+. So if you're doing H3PO4, I'd say, okay, well, let me give you an example. Let's say I got 3.0 molar H3PO4. And I ask you, well, then, what is your molarity of your H+ concentration? You would do 3.0 times you had 3 H's, so 3.0 times 3. That means I have 9.0 molar H+ concentration. So notice that if I have more than 1 H, I'm multiplying my molarity by the number of H's. So it does matter if something is monoprotic, diprotic, or triprotic. You've got to pay attention to whatever number they give you. You've got to manipulate. I also can do this with my bases. So they're asking me, well, is your base monohydroxy? Well, let's think mono is 1, hydroxy is OH. So here's my example, KOH. Well, that has 1 OH. So that would be monohydroxy. Well, if I'm dihydroxy, I think, well, di is 2. Example, BaOH2, it has 2 OHs. I could also be trihydroxy, but if I'm looking, I'm going to do this same thing. I'm paying attention to how many I have. So if I have, let's say I have 1 molar KOH, well then I just have 1 molar OH minus concentration. But if I had 1 molar BaOH2, I have 2 OHs. So I actually have 2 molar OH minus concentration. So you want to be very careful that I am manipulating my concentration based on how many I have. So let's do another example. We'll do it right on the side. Write it with me. So example. What volume of 2.5 molar HCl is required to titrate 50 milliliters of 3.0 molar CaOH2. Let's reread it. What volume of 2.5 molar HCl is required to titrate 50 milliliters of 3.0 molar CaOH2? Well, I see this word titrate. That's a lot like titration. So I'm going to try to use this. MAVA equals MBVB. So let's go through and let's see all the things that I have. So let me move it down a little bit. I know 2.5 molar, that is of your HCl. So that's your molarity of acid. Your molarity of acid is 2.5 molar. I know that because I just have one H. I don't know my volume. They're asking me to solve for it. So VA equals question mark. They tell me I have 50 milliliters of 3.0 molar CaOH2, but pay attention here, 2 OHs. So that means this number right here, this is not actually your molarity of base. Your molarity of base is actually 3.0 times 2, because you have 2 OHs. So that's really 6.0 molar for your molarity of base. So this is the number you'll want to use. And then here, they gave me your volume of your base. So I can go ahead and plug into my titration equation. I have 3 of the 4 variables, as long as I made sure I manipulated my concentration for my base, because there was more than 1 OH. So let's fill that out down here. So my molarity of acid was 2.5. My volume of acid was X, because I don't know. My molarity of my base was 6.0. My volume of my base was 50 milliliters. So if I go through and I solve that, I'm going to get 2.5x equals 300. If I solve for that x, I'm going to get x equals 120. It was a volume. My original volume was in milliliters for my base, so milliliters down here. I need 120 milliliters to neutralize or to titrate HCl and CaOH2. So remember that when you're doing a titration, I said it was called a neutralization because we know when I get an acid reacting with a base, I'm going to get a salt and I'm going to get water. And this is called a neutralization reaction, which you should know very well because we've been talking about these for a few days now. So neutralization reaction is always when I get an acid plus a base. So when I'm titrating an acid with a base. Okay, so then I want to just talk about the neutralization net ionic equation. So we're going to write this on page 11. So if you flip the very next page, page 11, and what you can do is you can cross out the using table J, because not that it's not important, but we've done that enough, I think. So go ahead and cross that out. And now, what we're going to do, they give us this example up at the top. Well, this was an example of neutralization. I have an acid plus a base. So I know I'm going to get a salt and water. So H2O I can write right there. My salt is, remember, the H and the OH makes your water. So I got the Na and the Cl. I always want to crisscross, but Na is +1, Cl is -1, so I get NaCl. Then make sure it's balanced. So that's a neutralization equation. And then actually right down here, actually let's draw an arrow. So we'll say right down here. Oops. Oh, that didn't work. So I'm touching it at the same time. Let's see. So neutralization arrow right down here. We're going to kind of continue. And let's say, so let's rewrite neutralization. And we're going to talk about the net ionic equation. So neutralization, again, is acid plus base, gives me a salt and water. We have the example that we just did above, but let's rewrite it. I had HCl plus NaOH. I formed NaCl and H2O. Now here's what I want to do. I want to look at all the pieces, the things that they will break into. Well, we talked about how acids and bases and salts are electrolytes. They are electrolytes because they have ions that they form. So HCl actually splits up into two pieces, H plus and Cl minus. NaOH does the same thing, only its pieces are Na plus and OH minus. If I look now, I have my arrow. NaCl is definitely ionic. It turns into Na plus and Cl minus. And then I have my water. Well, water is purely covalent. That means if it's purely covalent, no ions. So if there is no ions, then that means it's still just H2O. So what I want to do when I do the net ionic equation, it's important that basically I'm going to cancel out anyone that appears on each side. Like, so if it's on the reactant side and the product side. So on the reactant and product side, it's called a spectator ion. And spectator ions, let's just say that, they will appear on both sides of your equation. And they will be what makes up your salt. So in this case, when I'm looking, I've got, let's see, H over here. Well, I don't have an H over here. Cl over here. Ooh, I have a Cl over here. So Cl and Cl, those are actually, so there's one of your spectators, Cl minus. I also see Na plus. Oh, look, I got Na plus. So Na plus, Na plus. So Na plus is your other one. And then I just want to check, is it OH? Nope, I don't see an OH on the other side. I see an H2O. So spectator ions, I'm going to cancel. I'm going to take them right out. So they don't really matter. So Cl cancels with Cl, Na cancels with Na. And I'm just left with my net ionic equation for neutralization. I have H plus OH minus gives me H2O. So net ionic equation. It is always what is left after you cancel your spectators. So H plus OH minus goes to H2O. So your net ionic equation is basically the important part, what makes something neutral. That should make sense because water is neutral. It has a pH of 7. So that kind of proves that that's neutralization. So the net ionic equation for neutralization is right here. That will always be it because your salt will always be a spectator ion and cancel out. And the last thing I wanted to just tell you was right here, important for lab safety. It says, do what you oughta, add acid to your water, never the reverse. And really, this is just a safety tip. So lab safety tip, whatever you're doing, if you have to dilute your acid or your base, you always add your acid to your water, not your water to your acid in case it splashes on you. So, let's see. Anything else? I just want to do a couple practice problems. So last thing we want to do, we're going to do packet page 27. So please go there. Again, you should have your reference table right near you. And you should also have a calculator. So on page 27, it says, in the laboratory, a student performed an acid-base titration. So this is the setup for a titration. You would have something, this is called a burette. And what you'll do, you would start, it says the burette contains NaOH, so the burette has a base in it. And it says this, your flask contains HCl. So HCl means here's your acid, and it also has phenolphthalein in it. So if I go and I look, I'm going to look at the color change for phenolphthalein. It's an indicator. So I know that from table M, phenolphthalein goes from colorless to pink. I want to think, well, where is it colorless? It's colorless if I am below 8. So this is an acid. So right here, this would appear colorless. Then I'm going to add more NaOH into it, and we will see our color change. So it says, okay, the following data was collected. The volume of acid is 20 milliliters. So there's my molarity of acid. It's HCl 1. Oh, not my molarity. What the heck am I talking about? There's my volume of acid. So here's my volume of acid, 20 milliliters. It says the molarity of the acid. I know this is hard to see, but it says 0.5 molar. Well, the acid is just HCl. So there's one H, so this is your molarity of your acid. And then it says the volume of the base. So right here, I've got my VB. So the only thing I don't know is my molarity of my base. They might ask me for that later. A says, write the balanced equation for the reaction between HCl and NaOH. So I say, okay, HCl plus NaOH, acid plus base, gives me salt and water. I already know my water, and my water is made from my H and my OH, so NaCl must make up my salt, NaCl. So acid plus base gives me a salt and water. Do I have to balance it? Nope, I'm good. Now the next one says, okay, based on the data table above, calculate the molarity of the NaOH. So I want to think, okay, I have enough to use the titration equation. People often confuse the molarity equation with the titration equation. You use the molarity because I have enough. So it said, write the formula, show the work. Well, my formula, MaVa equals MbVb. Let's see what I know. My molarity of my acid was 0.5. My volume of acid was 20. My molarity of my base, I don't know. It's X, but my volume of base is 40. So I go through, I solve that, and you should get X equals 0.25. Now what did you solve for? A molarity, a concentration. So it is big M. Part C says, what color does the indicator appear? Well, the indicator, remember, was phenolphthalein. It went from colorless to pink. At the end point, well, it's when I change colors. So I start colorless, I turn pink. So I'll be pink at the end. And D says, what name is given to the reaction between equivalent quantities of acid and base? Acid plus base gives me salt and water. That is neutralization. I want you to, these problems right here, I want you to do now, right now. So pause it if you need to. I will be checking these tomorrow. I want the answers to these. And then the last question says, finish the following reactions and balance them, or write no reaction. Well, these, if I look over here, these are all single replacements. So if they're all single replacements, I want to think, and they're giving me the option no reaction, I better check table J. This is my reaction of acids with metals. So I go, remember, higher replaces lower. So I'm going to look up, does Mg replace H? Yes, it will. I have to crisscross. Mg is plus 2, Cl is minus 1. So I get MgCl2. And I will form H2 gas. I will need a 2 to balance that. If I look at table J, I'm also looking, is Al higher than H? Check it out. Yes, it is. Al, I'll do it over here. Al is plus 3. PO4 is minus 3. So if I crisscross, they go away. So my salt will be AlPO4 plus, I got to make H2 gas. I always make H2 gas when I have a metal and an acid. I have to go back through and balance this. I don't think I like that there's a 3 there, so I'm going to go ahead and put a 2. So that means I can put a 3 over here. But that means now I did 2PO4, so I have to put a 2 here and a 2 here. And the very last question, Ag going with H. You should see Ag is lower than H. So there is no reaction for that one. That metal does not react. And that is the end of the video. So thanks, guys. Make sure you had that problem done, which is number 2, A, B, and C. I'm checking it tomorrow. And that's it. Have a great day. Bye.